I am Anil Kumar. Welcome to my series on functions. Here is a test question for you on functions and transformations. You are given the graph of the function f of x. Based on this graph, you have to answer these 5 questions. First, find the value of f of 0 and f of 2. 2. Find the zeros of the function. 3. Find k, where f of k is equal to 1. Fourth, find domain and range of f of x. And fifth question is, sketch the graph of y equals to f of 4 minus 2x minus 1. You can pause the video, answer the question, and then look into my suggestions. Find the values of f of 0 and f of 2 means what is the value of the function at x equals to 0. So x equals to 0, the value of the function is minus 1. So we can write down f of 0 is equal to minus 1. At x equals to 2, the value is again minus 1. So the same value, right? And at x equals to 2, the value of the function is also minus 1, correct? Second question is to find zeros of the function. Zeros are the points where the graph of the function crosses the x-axis. So these are these 2 points. So it has 2 zeros. One is at x equal to minus 2. The other one is at x equals to 3. Now the third question here is, find k, where f of k is 1. So the y value is 1, that is given to us. We have to find at what x value will the value of the function be 1. So if I draw a horizontal line at y equals to 1, it intersects at 2 points which give you x value of minus 3 and 4. So the value of k is equal to minus 3 and 4. So at 2x values, minus 3 and 4, the value of the function is positive 1, right? Now we need to write domain and range of the function. Now, for the domain of the function, you have to carefully see that this point is included, but here we have an arrow. That means it extends. So as far as the domain is concerned, we can say, since it is a solid line, we'll say x belongs to real numbers where x is greater than equal to the value of minus 4, right? So, because everything is included here, right? And for range, y again belongs to real numbers, but the value of y is greater than equal to minus 1, right? So that is how you're going to get domain and range of this function. Now the fifth question is to sketch the graph of the function y equals to f of 4 minus 2x minus 1. You can pause the video, sketch the graph, and then look into my solution. I'll sketch it on a separate page. So I hope you got the graph of the transform function. Here is my suggestion. We are given the equation as y equals to f of 4 minus 2x minus 1. Now it is a must to factor minus 2 and rewrite this particular function. So we'll write this function as y equals to f of square brackets. We'll take minus 2 common. So when you take minus 2 common, you get x minus 2 within the brackets, correct? So that becomes the transformation. Now once you have the transformation, it really means what? This minus indicates reflection on y-axis, horizontally compressed by a factor of half. 2 units to the right, 1 unit down. That is the transformation. Is that okay? Now, the coordinate points x and y will not change to what? The x values will get multiplied by minus half. So I could write this as minus x over 2. and then you have to add 2, right? So that is how the x values will change. The y values will be decreased by 1 since the graph is translated 1 unit down. So that is the transformation of points. Now what we are going to do here is we are going to mark some points which will help us to sketch this graph. So we'll make a table. So writing xy points, and for each we'll write down the transformed points. So in our graph, the good points to take are those which are mentioned here. Let's say this is point A, this is B, then we have C. We can mark a point here D and then extend, right? These x-intercepts are also good points to take. Okay, so let me call them as P and Q. I don't want to take too many points. Anyway, so well we could take this P and Q also. Okay. So the coordinates of point A are at -4 it is 2. So at -4 the value is 2. At point P, which is the x-intercept, it is -2, 0. At B, we have the value at -1, -1. C, at 2 it is -1. Q, the second x-intercept is at 3. And D is 4, 1. Now we are going to apply the transformation mentioned here. That is to say, we'll do half of the x value and then add 2, right? Negative half. So negative half of -4 will be +2, and when you add 2 to it, you get 4, right? So you get 4. So this is A dash as the x value. The y value we have to decrease by 1. So we get 4, 1. Now let me write P dash. Half of negative will be 1 positive, and then we'll add 2. So we get 3 here. 0 minus 1 will give me -1. For B dash, -1 half is 0.5, and when I add 0.5, I get 2.5 or 2.5. The y value, when I do -1 to -1, it becomes -2. For C dash, the image, half of 2 is 1 with a negative sign. So -1 and 2 will give me 1. -1 minus 1 is -2. Q dash, the second x-intercept, half of 3 is 1.5 with a negative sign. So we get 0.5 or half. And as far as the y value is concerned, we get -1. 4 half is 2 with a negative sign, so it gives us 0. So D dash is 0, and 1 minus 1 is 0. So those are the transform points, right? So let us sketch the transform function starting with A dash, which is 4, 1. So basically, you can actually describe the transformation also. Let's also describe the transformation before we sketch it. So what do you notice here? The transformation is basically, if you read from the left side, it is reflection on y-axis, then translation 2 units right and 1 unit down. So 2 right and 1 down. That is it, right? So that is what is the transformation. So when you reflect on the y-axis, this arrow is going to go this side, right? And the whole graph is going to move 2 units to the right and 1 down. We'll actually place these points and then connect them. So A dash is 4, 1. So at 4, we have the point 1. So that is A dash now. This point will be A dash. Let me write A dash here in green. 3 minus 1. So at 3 minus 1, we have 1 point, which is B B dash. B dash is 2.5 minus 2. So at 2.5 we get minus 2. So 2.5 is there and minus 2 will be here, right? So when you connect, this will come to this point. Then we have at 1 minus 2. So at 1 also it is minus 2. Now this point is B dash, C dash 1 minus 2, and B dash is this. Okay. Q dash, half minus 1. So at half we have minus 1. And then at 0 we have 0. At 0 we have 0. Correct? So that is how the graph is. Now, as you can see, this D is extended, right? So this graph here will have this arrow this side, right? So when you connect these points, you get an arrow like this. It extends to this side. And connecting here, we get a fixed point here. So that becomes the graph of the function, which you can see clearly has been compressed horizontally. So width has been reduced to half. That is because of this, right? Reflected on y-axis, the arrow moves into left side. So that becomes your transformed function. Y, we can call this as g of x, right? So let's call this g of x. So that is how you're going to sketch it. Now, as an exercise, what you can do is, you've already seen the domain range of the function. You need to write domain and range of transformed function. I hope the solution of the question is understandable. We first figured out how to read the graph by finding the points on the graph, and then we transformed the function. The important thing was to factor the inside terms and get the right transformation. If you don't do that, you can make a mistake, right? So that is kind of very important to understand. Hope you understand and appreciate it. Feel free to write your comments and share your views. If you like and subscribe to my videos, that would be great. Thanks for watching and all the best.